Hello everyone, I am Bhanupriya DA from Sri Venkateshwara College of Engineering from Data Science Department. Today we are going to discuss about vector calculus, which is a subject in mathematics. Vector calculus, the art of mathematical manipulation. These are the contents in this presentation. Coming to introduction to vector calculus is a branch of mathematics that deals with the study of vectors and their properties. It is an important tool for understanding many physical phenomena from the motion of planes to the behavior of fluids. Vector calculus is also used extensively in engineering, particularly in the fields such as electromagnetism and fluid dynamics. Vector calculus involves the manipulation of vectors and their derivatives, but this is an actually fascinating and accessible subject that has many practical applications. If you are interested in physics or engineering or computer graphics, this vector calculus is an essential tool for understanding the world around us. Vectors and scalars. In vector calculus, we often deal with two types of quantities, that is vectors and scalars. Scalars are simply numbers that have magnitude but no direction, such as temperature or mass. Vectors, on the other hand, have both magnitude and direction, such as velocity or force. Vectors are used in vector calculus to represent physical quantities that have both magnitude and direction. For example, if we want to describe the motion of an object, we need to specify both its speed, that is scalar, and its direction. Direction is a vector. In addition, vector calculus allows us to perform operations on vectors such as adding or subtracting them, finding their dot product or cross product, and taking their derivatives. Here you can see the examples of scalar and vector. Scalar is speed, mass, volume and time. Vector is velocity, weight and friction. Vector functions. In vector calculus, a vector function is a function that takes one or more inputs and returns a vector as an output. Vector functions are used to describe motion and forces in physics as well as in other fields such as computer graphics and engineering. One example of vector function is the position of function, which describes the position of an object at any given time. Another example is the velocity function, which describes the rate at which an object's position is changing over time. Gradient, divergence, and curl. In vector calculus, there are three fundamental operations that are used to analyze vector fields. Firstly, the gradient. This gradient, it represents the rate of change of a scalar field in a space. Divergence, this measures the tendency of a vector field to originate or converge at a point. Coming to curl, this curl describes the rotation of a vector field around a point. Applications of vector calculus. Vector calculus has a wide range of application in the field of physics, engineering and computer graphics. In physics, it is used to describe the behavior of electric and magnetic fields, fluid flow and gravitational forces. Engineers use vector calculus to design machines, structures and systems that can withstand various forces and stresses. Computer graphics, it rely heavily on vector calculus to create realistic images and animations. One example of vector calculus in action is the study of fluid dynamics. By using vector calculus, scientists can model the behavior of fluids in complex systems such as oceans, weather patterns, and blood flow. Another example is in computer graphics, where vector calculus is used to simulate the movement of light and shadows in virtual environments. There are some more applications of vector. Few applications of vector are forces, torque, and velocity. These vectors are like vector calculus is also used in military usage and in projectile, and it is used in gaming also, and designing roller coaster in cricket and avoiding crosswind. In conclusion, we have explored the fascinating world of vector calculus and its many applications. We have learned about vectors and scalars, vector functions, and the fundamental operations of gradient, divergence, and curl. We've also seen how vector calculus is used in fields such as physics, engineering, and computer graphics, where it plays a crucial role in solving complex problems and creating innovative solutions. By this end of this presentation, I just want to tell you a thought, that is, vector calculus is not just a subject to be studied, but it's a tool to be utilized properly. By mastering the concept, whatever I have told in this presentation today, you will be like equipped to tackle some of the most challenging problems in your field and make a real impact in the world. So go forth and explore the wonders of vector calculus. Whether if you are a student, a researcher, or a professional, there is always more to discover and achieve. Thank you. Please do like, share, and subscribe my YouTube channel.